Warning, this video will contain some of the hardest questions you'd find on paper 2 higher tier. So as a tip, I would leave it till the end so you have enough time to do the rest of the questions. It should be easier to get marks on. And just like with paper 1, there will always be 1 or 2 weird questions. So find out what the question is about first of all, and if in doubt, say something you know is true or know is correct to help you at least start the answer, because 2 out of 5 marks is better than 0, so please don't be freaked out by them. Now, there are some common tricky questions that come up in paper 2, and we can prepare for some of those today and look at some kind of weird ones as well. First one is force diagrams, okay, which do come up relatively regularly and do confuse people sometimes. I'm talking about the ones that are perpendicular to each other. Then we've got conservation of momentum questions, and then we've got kind of those random questions which seem a bit kind of different. Now, in addition to those, you also have ray diagrams, which I've done an exam question video about already. You also have multi-step questions, which again I've done a video about, so I'm not focusing on those today. So let's be brave and let's dive in.
Question is about forces, and this could come up in separate or combined science, but it is a higher tier only question. Okay, so generally speaking, forces are relatively straightforward. When we talk about forces, we represent them with arrows, and we normally have them in the same plane, i.e. if I've got, let's say, 90 newtons upwards, 80 newtons downwards, the resultant is going to be equal to 10 newtons in the upwards direction. However, in this question, it's a little bit different, so let's have a look. Now, it gives us a boat. There is a tension force. Here's the force which we are talking about, and it says it causes a horizontal force and a vertical force. Now, you need to know horizontal is this way, vertical is this way, okay? And it asks us to find essentially the magnitude of the resultant. So on the next page, it gives us a grid and says draw a vector diagram to determine the magnitude of the tension force and also the direction. So we're going to look at how we go about doing that today. So before we get started with the diagram, let's just kind of plot out what we're going to draw roughly, okay? So we've got a force going up and a force going left. Okay, those are the two forces it tells us about in the question. So the vertical force upwards, I'm going to change this to 50, because it tells us it's 50 newtons, and it says horizontal force is 150 newtons. Now, to be able to draw our diagram, we are going to need to draw it to scale. A vector diagram, the clue's in the fact that it's a grid, it's got to be to scale. So when you're drawing out here, you haven't got 150 centimeters or 50 centimeters, you're going to have to decide a scale. Now, there are a few different ones you can use. The scale I've decided to use for this question, I'm going to basically do 25 newtons is 1 centimeter. Okay, you could probably do bigger, but I've not got the whole thing on the screen, so I'm going to do a bit of a smaller scale. Now, be careful when drawing it, because if you do too small or it's not accurate enough, you're not going to get the correct answer. Okay, so what I'm going to start off with is a dot. This is my object. Okay, you don't have to label it. I'm just going to put it on here though, so it's a reminder that's my boat. You don't need to draw on the boat, but that's this point here basically. Okay, next we're going to draw on. Again, you'd use pencil, and we're going to do pen because it shows up better on the camera. Now, if I've got 25 newtons is 1 centimeter, then that means that to scale, this is then 2 centimeters. So I'm going to draw 2 centimeters going upwards. Now, it does correspond with the lines on the grid, but it won't always be perfectly necessarily, so just use centimeters. And the other way I'm going to do is I've got 25 newtons is 1 centimeter, and that means this one here is going to be 6 centimeters, because 6 times 25 is 150 newtons. So 6 centimeters going to the left, okay, as accurately as you possibly can. And that's a couple of marks already, to be honest. It's 4 marks for this whole question. I'll show you what the marks are for in a second. But that's a fair bit of our work done already. Now, the whole point of doing this diagram is to determine the magnitude of the tension force. Now, we can see here the tension is going kind of diagonally. So the way we've drawn it here, what we've got to do is to figure out what this overall resultant force is going to be. So to be able to do that, and again, do this in pencil, I'm just going to draw like a couple of construction lines at the end to make this whole thing into a rectangle, and then we're going to go from the boat to the corner to find out what the resultant force is. Okay, so do it as accurately as you can, and then once we've found that, what we're going to do is measure it. And I'm going to label these on as well, just to remind me to go back into newtons at the end, because we have to give our answer in newtons. But let's measure it in centimeters. Well, this ruler actually does millimeters, but it's the same thing. So going from here to about over here, I'm going to say it's about, for me, 6.4 centimeters. So I'm going to say 6.4 centimeters. Next, we've got to figure out what that is in newtons. Okay, so I'm going to use my scale from earlier. So 1 centimeter is 25 newtons. So therefore, I'm going to do 6.4 times by 25. That's for my conversion. You might do this question slightly differently. So using my scale, that comes out to 160 newtons. So that will be the value of the resultant force that I put in the answer column. Okay. Now, as well as that, in the answer sheet, in the answer section of the sheet, so that's 160, which is in range. There'll always be a range with these kind of things. It also says direction of the force. Okay. Now, direction, we might be tempted to say left, right, up, down, west, north, east, etc. But whenever it says direction, what it means is the angle. So you need to bring a protractor with you to your physics exam, because there could be the odd mark or two that comes up that you'll need a protractor to do. So the bit we have to measure then is this bit protractor here, which I will do in a second, but basically you find that as an angle, and that should go in here. Okay, now for me that equals 20 degrees, and there's always a range with this as well, so that would be your last mark for this question. So there's one for the correct diagram, one for the force, one for this, and one for the direction as well. For our next question, we're going to look at a conservation of momentum question. So the calculations in this, you only need to know if you're doing separate science, but you do need to know the general principle if you're doing a combined science higher tier. So the question in general here is for separate science only. So we'll do the whole thing, even though the first mark should be relatively straightforward. Momentum is conserved means momentum before the two hockey players collide equals the momentum afterwards. If it was 2 marks, you'd say in a closed system, but you don't need to. We say no external forces, but we don't need to worry about that here, but I'll put it in brackets in case it's a 2 mark question. Next, for the really tricky bit. Okay, so it says immediately after a collision, the two players move off together to the right. Calculate the velocity of the two players immediately after the collision. Okay, now do definitely go and check out my video about momentum and conservation of momentum, because there are a few different versions of this calculation you could get given, and each one depends on the situation itself. Let's have a look at this one. We've got two ice hockey players move towards each other in opposite directions. They then collide, and then they move off together. Okay, now even if you don't know how to attack this kind of question, the clue in the first bit of the question is we need to use conservation of momentum. So from your equation sheet, the general equation for momentum is equal to mass multiplied by velocity. So even if you don't know what to do after this point, you should be able to work out the momentum before the collision just by looking at the numbers in the question. Okay, now I'm going to use player A and B just because it mentions that in the question, and it's always useful to do that because that's what will be on the mark scheme as well. So let's have a look at what we can calculate first of all. So momentum before player A is equal to 78 kg times by 7.5 meters per second. Player B is 91 kilograms times by, and this is really important, this is a negative sign, so it's times by minus 5.5 meters per second. Okay, now as a quick recap, minus doesn't mean it's invalid or it's it's slowing down, whatever. It just means it's going the opposite direction. Okay, velocity is a vector, so to indicate one's going one way, one's going the other, one's positive and one is negative, but it does make a difference to our calculations. So let's put these numbers into a calculator. Player A, if you type in 78 times 7.5, is going to be 585 kilogram meters per second. Player B is going to be a negative number. If you times a positive by a negative, you get a negative number, which is 500.5 kilogram meters per second. Now for the total momentum before, you have to add these two things together. So add them together and you'll get a value of, so essentially subtract 500.5 from 585 will give you 84.5 kilogram meters per second. So even though I haven't solved the question yet, I've got a couple of marks already, which is not bad going. Now to finish off this question, we should know, just because we've written it down, that momentum before has to equal the momentum after. Okay, that's what we wrote down over here. So therefore the momentum after has to be what we've just calculated. It can't be lost at all. Okay, so momentum afterwards must equal the same thing, 84.5. Okay, so what that means is that if I was to treat both of the ice hockey players as together, because the question does say they move off together, okay, so they're basically now considered as one object, traveling in a certain direction, they both have a momentum together, 84.5. Now we also know their mass, because we know their masses individually, so we add those together. Okay, so that means 84.5, our momentum is going to be equal to the total masses, so I'm just going to put this down here, mass 1 plus mass 2 times by the velocity which we're trying to find, which we don't know. Now we do know the masses, so let's put the numbers in. So 78 I should put mass A plus B in here, really, so 1 and 2. 78 plus 91 times by the velocity. Okay, now we've only got one variable we need to find out, and I'm running out of room, which is a bit of a pain, but let's go into the sheet here. So we've got 84.5 divided by these two added together, so that should be 91. So divide by that, 169, and that gives us a velocity of 0.5 meters per second. Okay, now it's a positive answer, so that would indicate, you don't need it for this question, but that means that the two of them together are still going to the right, because that's our positive direction from earlier. But there's our 4 marks for that question. Okay, now for the last part of the question, it's not particularly tricky or unusual, but I think it's definitely worth looking at, because I realise I haven't done an exam question on it, and for separate science, again, it comes up a lot. So it says the ice hockey players wear protective pads filled with foam. Explain how they help reduce injury when the players collide. Now, questions like this come up all the time. Often they'll have the word, or use ideas about momentum to help explain why they reduce injury. Okay, and it's the same mark scheme each time, basically. To reduce injury, essentially what that means is you have to think of a way to reduce the force that's acting on the people or their knees or whatever they've got. Okay, now how that happens is, and I would definitely use the equation to help remind you about it. There's an equation that says force equals change in momentum, or change in mv, divided by time. Okay, now anything that's to do with safety or to do with protecting or reducing injury and things like that doesn't have to be pads, car bumpers, it could be seat belts, it could be whatever. Okay, the reason they do it is because of this. Okay, now in this equation, because time is on the bottom, if you were to be able to increase the time taken for a collision, you are going to decrease the force. Okay, so the mark scheme looks something like this. So you'd say the pads increase the time taken. That should be an M, time taken to collide or for the collision or when they hit the ground. So that then reduces the force. Okay, now you might notice there's only 2 things we've said so far. So for our last mark, we've got to use what's in the equation as well. So the bit we haven't talked about here is momentum. Okay, so there's a couple of ways of phrasing this bit. You could say it reduces the rate of change of momentum. Another way of saying it, you can say it reduces the acceleration. That's usually allowed on mark schemes. So reduces acceleration. From that, you'd kind of use the idea of F equals m times a. But that will be your 3 marks for that question. Okay, for this question, this is definitely one of those questions where you'll be like, oh my god, I've never seen anything like this before. It's from 2021, and it was actually from the foundation tier combined science paper. So that means it could come up on any paper, really. It's not high tier, it's not separate science, it's kind of a bit of everything. Okay, so a lot of information to digest, and it is a 6 marker. Okay, so let's have a look at how we go about answering a question like this. So the question says, a rocket airplane will fly at a greater height than an jet airplane. The height that it flies at affects the radiation dose a passenger receives. And it gives us a table with some different details about a rocket airplane and a jet airplane. It tells us their speed, tells us the radiation dose each hour in millisieverts, which is just the unit. You don't have to worry too much about that for now, just the numbers are important. Then it says exposure to ionizing radiation has risks and possible consequences. Okay, so this is a bit of kind of crossover stuff. This could be on paper 1 when we talk about radioactivity. However, it's not, it's paper 2. And the question says evaluate the risks and possible consequences of flying in a rocket airplane and in a jet airplane, and assume the same journey is made in each airplane. Okay, so the one thing you should know, even without looking at the table, are to talk about the risks and consequences of like the radiation dose, but we're going to come on to those last. So let's have a look at the slightly trickier bit first. So for the rocket airplane, it travels a lot faster, and don't forget you can do this in bullet points. Any 6 marker you can do it in bullet points. So for the rocket airplane, so it travels faster, and the question mentions that it's the same journey. Okay, so it travels the distance in a shorter time. Okay, so shorter time in the air. Okay. Next thing to note is actually, even though it's a shorter time, the person in the rocket airplane will have a greater dose per hour than the jet airplane. So I'm going to talk about this in terms of the rocket. Again, you could say the jet engine, but I can say the rocket has a greater radiation dose. Now, for fascination, you are going to need to work out some calculations. That's why they've given you numbers here. Okay, so we need to figure out how much faster does it actually travel, so therefore how much shorter time is it. Okay, so this one's traveling at 8,000, and the jet airplane is traveling at 250 meters per second. So therefore, the rocket airplane, 8,000 meters per second, divided by 250 to find the ratio between them, turns out 32 times faster than our jet airplane. So if it's traveling the same distance, it's going to take 32 times less time. Okay. Next thing to talk about was this one's a little bit easier, which is how much more radiation. So greater radiation dose, double the jet airplane. Okay. Now pulling both those factors together, here is that if you've got 32 times less time in the air, but you double the jet airplane dose, okay, overall you're going to have basically 16 times less dose than the jet airplane. Okay, because the jet airplane has a lower dose, but it spends 32 times more time in the air than the rocket airplane. So overall, you'd have essentially 32 times by basically a half. Therefore, you're going to have 16 times less dose in the rocket, basically, because the main factor is how quick it goes, as opposed to just the dose. Okay, now to finish off, and this should be the easier bit, so well done if you got this far. I know it's quite a tricky question, to talk about the risks and possible consequences for ionizing radiation. So those bits are the same thing as at paper 2. The risks are essentially that you're going to have higher risk or higher risk in the jet, because you've got less time, as we've calculated, less risk in the rocket. So therefore, increased risk of gene or DNA mutation, cancer, etc. Okay, so there we go. So that's us for that question. The maths isn't too tricky, but obviously interpreting the question is. So my top tip would be, well, at least everyone knows the consequences we should know of ionizing radiation, and make some relevant calculations comparing the two things. Will get you some marks, even if it's not 6 out of 6, but that's how you get 6 marks for that question. For our last question in this video, we are going to look at a question from 2018, the very first year the specification was given out, and it's from the separate science only, because it's asked about space and orbits, so it is separate only. However, the skills involved apply to everyone, so it's definitely worth having a look, even if you're doing combined science. So the context is, as there's the Earth and there's a satellite orbiting around it in the previous bit of the question, and it says the graph shows how the length of the satellite orbit depends on the height of the satellite above the Earth's surface. And we've got the graph here. It says the satellite orbits 300 kilometers above the Earth's surface at the speed of 7.73 kilometers per second. Calculate how many complete orbits of the Earth the satellite will make in 24 hours. So there's an awful lot of information there, and it's 5 marks worth of working out we've got to do in the question. Now, because there's a graph, there's always got to be something to work out from the graph. So that's the first thing we're going to do. So even if you can't get all marks in this question, let's at least use the graph successfully. So it says the satellite is orbiting 300 kilometers above the Earth's surface. This axis shows height above the Earth's surface, so let's use the graph to find out something else. Alright, since one of the other questions I managed to lose my ruler, so you definitely use a ruler and real thing. However, for now I'm going to go across freehand just to show you what the value is going to be. Alright, so 300 kilometers above the Earth's surface gives you a length of orbit of 42,001 square, so 42,100 above. So let's write that one down here. So 42,100 kilometers length of orbit. So 24 hours, we've got a time there. We've also got to work out how many complete orbits. So let's go back to our little diagram from earlier. So imagine if the satellite is going around and around the Earth. If we know the length of an orbit, then what we can do is figure out basically how many of those might be in 24 hours. And to do that, we need to use speed, distance, time to work out the time taken for one orbit, and then to figure that out. Okay, so speed equals distance times time. Well, the distance taken for one we just worked out, so 42,100 The speed is 7.73, that's what it says in the question, and the time we don't know. Now I'm not converting units here because both are in kilometers. Okay, you could put times 1,000 times 1,000, doesn't matter, they'll cancel out anyway. But to work out the time, I'm just going to leave it as it is. So let's rearrange 42,100 divided by 7.73, and that will tell us the time for one orbit, which happens to be 5446 seconds. And our last job is to figure out how many of those are there in 24 hours. So to be able to work out in 24 hours, we need to figure out how many seconds there are so we can compare them directly. So 24 hours is 24 times 60 times 60, which is 8640. And that's how many seconds there are in one full day, and that's how long it takes for one orbit. So essentially how many 5,446 seconds are there in that, so we divide them. So for the number of orbits, 86400 divided by 5446, which should give us 15.86 something, and it says number of complete orbits, so it doesn't make 16, so it only makes 15 orbits overall. And that's the end of that question. So I hope you found that useful. That's how you deal with questions which are a bit weird, a bit different. Keep your cool, remember the basics, and always try and get at least a couple of marks, so you never know where it might take you. But thanks very much for watching.